Now that we've looked at different types of reactions and we've started to look at what species are present in the solution so that we can determine what kind of a reaction is going to take place, it's necessary to take a look at how much of that stuff is in solution, or the concentration of those solutions, the amount of solute dissolved in the solution. You might get a cup of coffee and think, that's really strong coffee. There's a lot of coffee compared to water. In chemistry, we would use the word concentrated for a solution with lots of solute in the solution, and dilute if there's very little solute in the solution. Remember, we use the words strong and weak to express the degree of ionization of acids and bases and soluble salts. We express the concentration of a solution as molarity. And molarity is moles of solute over liters of solution, or moles per liter. And bear in mind that that is the total volume of the solution, not the volume of the solute. So very often you might be given a mass of solute in grams. And if that were the case, then you would need to convert them to moles using the molar mass of the compound to plug in to calculate the molarity of the solution. Also, as molarity is measured in moles per liter, if you're given milliliters, you're going to need to convert that to liters as well. Here's a practice problem we can try. If I dissolved 5 grams of potassium carbonate in enough water to form 250 milliliters of solution, what would the molarity of the solution be? Now my solute, the substance being dissolved, is the potassium carbonate, is given to me in grams, and I know that molarity is moles of solute per liter of solution. So I'm going to need to take those 5 grams of potassium carbonate and convert them to moles. And I will do that using the molar mass of the compound, which is 138.21 grams per mole. And so we get 0.0362 moles of the potassium carbonate. Now I need to divide that by my volume in liters. And since I'm given 250 milliliters, I know that there are 1,000 milliliters in every liter. And you can do that by moving the decimal place over 3 places, and you would find that your volume was 0.250 liters. And when we divide, we find we have a molarity of 0.145 molar. Sometimes it's necessary to know the concentration of ions in solution. So if the molarity of the potassium carbonate solution is 0.145 molar, what's the concentration of potassium ions in the solution? Well, we know potassium carbonate is an ionic compound. It's a soluble salt. And so what happens when we put solid potassium carbonate into water is that it is going to dissociate into its respective ions, and it's going to form 2 potassium ions and 1 carbonate ion for every formula unit of potassium carbonate. So if we have a molarity of 0.145 molar solution of K2CO3, and every 1 mole of potassium carbonate contains 2 moles of potassium ions, then the concentration of potassium ions in the solution would be 0.290 molar with respect to the potassium ions. So eventually we would use this information to consider the stoichiometry of a particular solution, and so it's necessary to convert between moles, molarity, and volume. An easy way to do this is to use the triangle. And so if molarity is moles over liters, or molarity is moles divided by liters, that's our regular formula, okay? If we wanted to calculate liters of solution, it would be moles over molarity, or moles divided by molarity. And if we wanted to calculate for moles, it would be molarity times volume. And so this is just an easy way of algebraically rearranging the equation for whatever you need to solve for. Let's say we want to make 350 milliliters of a 0.5 molar sodium sulfate solution. How many grams of sodium sulfate do we need? First of all, check your units. 350 milliliters is 0.350 liters. Now we're solving for grams, and I can convert to grams if I find the moles of the solute. And if I use my triangle, I know moles is going to be molarity times the volume. And the molarity, according to the problem, is 0.500 molar. The volume in liters is 0.350 liters. And we get 0.175 moles of sodium sulfate. Once you know how many moles you have, then all you need to do is convert moles to grams using the formula mass of the compound, which is 142.04 grams per mole, giving us 24.9 grams of sodium sulfate. And we would add that 24.9 grams of sodium sulfate to enough water so that we have a total of 350 milliliters, or 0.350 liters of total solution. When I buy hydrochloric acid to use in the lab, it comes in a bottle of 12 molar concentrated solution. We call this a stock solution. Now what I do is I take this 12 molar acid and I dilute it to a concentration that's going to be a lot safer to work with in the lab. And the formula that we use to make that dilution is M1V1 equals M2V2, where the M is referring to the molarity, the V is referring to the volume, M1V1 is with reference to our stock solution, M2V2 is with respect to the dilution that we are preparing. And to prepare a dilution, I like to use a volumetric flask, which is a measuring device that is calibrated for a specific volume. And in this instance, there's a line right there. Filling up to that exact line would give you exactly 250 milliliters of solution in the volumetric flask. So what I'm going to do is I'm going to take a small volume of this really concentrated acid and add water to it to make it dilute, and do that in a different container. And that's how I would prepare my dilution. So let's say I want to prepare a dilution from that 12 molar stock solution. I need 250 milliliters, and I want the molarity to be 0.1 molar. So how am I going to prepare that solution from the 12 molar stock solution? So going back to my formula, M1V1 equals M2V2. Remember, that's my stock, and that is my dilution. And I know that my stock solution is 12.0 molar. What I want to know is what volume of that am I going to take out of that bottle to prepare the dilution that I'm going to prepare. The molarity that I want to prepare is 0.1 molar. The volume that I want to prepare is 250 milliliters. Now, we know that molarity is moles divided by liters of solution. When we're preparing a dilution, it's okay to leave your volume in milliliters because we're going to be working in milliliters, and it's the same units on both sides of the equation. So this is the one time when it's okay, dealing with molarity, to leave your volume in milliliters. So if we solve mathematically for V1, we get 2.08 milliliters. So I'm going to take that volume, 2.08 milliliters, out of my stock solution, and I'm going to add that to enough water to make 250 milliliters of my total solution. Now, the one thing I'll mention now, and we'll talk about this again later, is that we have a rule about adding acid to water, because the addition of acid to water is highly exothermic. We would want to have some water already in our volumetric flask before we go ahead and add the acid to it, so that the heat would be allowed to dissipate throughout the solution. So I would first prepare the solution by adding some water to my volumetric flask, and then adding my 2.08 milliliters of acid to that, and then finishing off by adding water until I got to my desired volume of a total of 250 milliliters. And that's how I would prepare a dilution.